3.
Hi and good evening everyone. So today we are going to present our assignment 2, which is Malaysian Cultural Arts and Geometry. So we are from group 3H. So these are my family member. I am Ernie Harry. This is Nur Akida, Nurnisa Shamimi, Nur Azila and Muhammad Razif. So for the table of content, we are going to start with the introduction, followed by geometrical shape, geometrical concept and measurement, transformations in motif, transformation in shape, summary, conclusion, and the last one is AI detection result. So for the introduction, the object which are being studied is called as Islamic geometrical lattice and also known as Mashrabiyah or Jalil screen, and it functions as decorative architectural panels. So it is originated from traditional Islamic architecture which are found in Middle East, North Africa and also South Asia. So it is designed based on Islamic art principle, which are geometry, symmetry and also unity. So it is commonly installed in mosques, university or government buildings, and the object being studied is located in Masjid Al-Mushridin, which is located in Sultan Idris Education University. For the size of the object being studied, it has a measure approximately 3.0 meter height and 1.7 meter width. And the function of the object and the main function of it is it acts as decorative tools, and it also provides privacy, also act as light control, and the last one it also allow air ventilation.
Next is the geometrical shape. Several patterns can be observed on the wall carving panels. This pattern consists of geometrical shapes such as rectangle, right angle triangle, isosceles triangle, rhombus, regular hexagon, and isosceles trapezoid. Each geometric shape has been identified based on its unique properties and characteristics. First one, we have rectangle. The rectangle can be seen in the outer front of the panel. It has 4 right angles with opposite sides in parallel and equals in length. Second, we have right angle triangle. Right angle triangle, which consists one angle measuring 90 degrees. This shape can be observed in several decorative sections of the carving pattern. The third one is isosceles triangle. An isosceles triangle is a triangle that has at least 2 sides of equal length. The 2 sides are called as leg, and the third unequal side is the base. Like all triangles, the sum of all internal angles always equals to 180 degrees. The fourth one is rhombus. Rhombus is a quadrilateral with 4 equal sides. It diagonals intersect at right angles, creating an interactive diamond-shaped pattern within the carving. Next, we have regular hexagon, a 6-sided polygon. In a regular hexagon, all sides are equal and each interior angle measures 120 degrees. This shape forms one of the main repeating patterns in the panel. Last one is isosceles trapezoid. The isosceles trapezoid can be found at the lower section of the design. It has 1 pair of parallel sides, while the non-parallel sides are equal in length, giving it a symmetrical appearance.
Next is geometrical concepts and measurements. For geometrical concepts, is the basic ideas in mathematics that help us to understand the shapes, size, relative position of objects, and the properties of space. Next, for measurements, measurements is a process of quantifying the physical properties of characteristics of an object. For example, measure the length, width, height, and area of the object. In this project, we identify several geometric shapes from a real object. Now let's begin with a rectangle. So since a rectangle is a quadrilateral with 4 right angles where opposite sides are equal and parallel. Based on our measurements, the length of the rectangle is 3 meters and the width is 1.7 meter. To find the angle, we use this formula, and the total angle of the rectangle is 360 degrees. For the perimeter, we must add all the length of each side, and the result is 9.4 meter. For the area, we use the formula A equals to base times width height, and the result is 1.5 meter squared for the rectangles. Next, we have the rhombus. A rhombus is a quadrilateral where all 4 sides are equal in length. For this shape, each side's measure is 0.05 meters. And to find the angle, for each angle, we use these formulas, and giving out each angle is equals to 90 degrees. For the perimeters, Same to the rectangle, we add all the length of each side and the result is 0.3 meters. For the area, we use the formula 1/2 times with first diagonals times with second diagonals, the length of the diagonals, and the result is 0.28125 times with 10 to the power of negative 3 meters squared. Moving on to the regular hexagons. A regular hexagon consists of 6 equal sides and 6 equal angles. Each side of the hexagon's measure is 0.075 meters. To find the interior angles, we use these formulas, and the interior angles is equals to 120 degrees. To find the perimeter, we use the formula n sides times with the length of each side. So, for this regular hexagons, the perimeter calculated was 0.45 meters. And for the area, we use the formula 1/2 times with a quarter times with perimeters. And the result is 7.875 times with 10 to the power of negative 3 meters squared. The next shape is a right angle triangle. To verify that is a right angle triangle, we apply the theorems, Pythagoras theorems. Since it is justified the theorem, so we can say that the triangle is a right angle triangle where one of the angles is equals to 90 degrees, and the perimeters for the right angle triangle is equals to 0.12 meters. For the area, we use the formula 1/2 times with the length A and B, which is A and B is the legs of the right angle triangle, and the result is 6 times 10 to the power of negative 4 meters squared.
Okay, for the isosceles triangle, an isosceles triangle has two equal sides. In our measurement, AB equal to AC equal to 0.075 meters. According to the isosceles triangle theorem, equal sides have equal opposite angle. Therefore, angle B equal to angle C, which is 35 degrees. Using the angle sum of triangle, angle A equal to 180 degree minus 35 degree minus 35 degree equal to 110 degree. Okay, for the perimeter, we sum of this perimeter, we can get 0.075 plus 0.075 plus 0.115 equal to 0.265 meters. And for the last, for the area is, the area was calculated using that formula, which is area equal to 1/2 times base times height, which give 2.768 multiplied by 10 power of negative 3 square meters. This confirms the geometric properties of an isosceles triangle. Okay, for the last part, we have the isosceles trapezoid. An isosceles trapezoid has one pair of parallel sides and two equal non-parallel sides. Okay, the measurement obtained are AB equal to 0.055 meters, for CD equal to 0.160 meters, and for AC equal to BD equal to 0.075 meters. Since the non-parallel sides are equal, the shape is classified as an isosceles trapezoid. The perimeter was calculated as P, and then we get the perimeter of this isosceles trapezoid is 0.365 meters. And for the area, we use formula area equal to 1/2 times height times base 1 plus base 2. And substitute the value, we get the area of this isosceles trapezoid is 5.805 times 10 power of negative 3 square meters.
Next, I will explain about the transformation in motifs and patterns. So the first one is a pattern. A pattern is a design in which line, shape, or forms or color that are repeated. The part that is repeated is called a motif. So what is a motif? Motif is any pattern that begins with a single element that will be repeated. A motif can be rearranged and repeated in variety of ways to produce a variety of pattern. So the transformation could be rigid where the shape of or size of the pre-image is not changed, and non-rigid where the size is changed
but the shape remain the same. There are four major types of transformation, namely rotation, translation, dilation, and reflection. So this is the transformation in motifs. So the first one is the reflection in motifs, which the first one, the figure A, is illustrate the transformation of reflection. So if you guys can see here, the rectangular hexagon labeled A, B, C, D, E, and F is the object, while the P, Q, R, S, T, and U is the reflected image. The line JK acts as the line of reflection, which is the mirror line. So each of corresponding point is at an equal distance from the line JK. So therefore, the motif demonstrates a vertical reflection across the line JK. So the next one for transformation is in motif is the rotation in motif. So the figure B illustrates the transformation of rotation, which the rhombus ABCD label ABCD is the object, while EFGH is the rotated image. The motif is rotated about its center point in a clockwise direction. So the angle of rotation is 180, representing a half turn. So the corresponding vertices are mapped as A to G, B to F, C to E, and D to H. So the shape and the size of the rhombus remain unchanged after the rotation. So the third one is translation in motif, which figure C illustrates the transformation of translation. So the upper regular hexagon labeled A, B, C, D, E, and F is the object, while G, H, I, J, K, L is the translated image. So the motif is translated vertically downwards, so each vertex moves the same distance and the same direction. The corresponding vertices are mapped A to G, B to H, C to I, D to J, E to K, and F to L, where the shape, size, and orientation remain unchanged. So for the transformation in patterns, we have one, which is the reflection in pattern, where figure D illustrates the transformation of reflection in the geometric pattern. So line ST will act as a line of reflection, which is a mirror line. The motif on one side of the line ST is reflected to form identical motif on the opposite side, and each corresponding point is equidistant from the lines ST. So the pattern is exhibit a bilateral symmetry. So therefore, the pattern demonstrates a transformation of reflection.
Okay, for the summary, many geometrical shapes can be found around us. For example, several geometric shapes were identified from the design of the wall paving panels located at Masjid Al-Mushidin. From there, we can see it has geometrical shapes such as rectangle, right triangles, isosceles triangles, rhombus, regular hexagon, and isosceles trapezoids. Each shape has its geometrical properties, measurement, perimeter, area, and angle relationship. Mathematical formulas and geometric theorems were applied to determine the dimension and characteristic of the shapes found within the design. Overall, the study demonstrates how geometry is integrated into architectural design to create visually appealing and mathematical structural patterns. For the conclusion, through this assignment, a better understanding was gained regarding the practical application of geometric concepts in real-life structures, particularly in Islamic architecture. The latest screen at Masjid Al-Mushidin demonstrates the significant role of geometry in architectural design. The combination of different geometric shapes and transformation creates a structure that is not visually attractive but also mathematically organized and functional. For addition, by completing this assignment, our group can learn to communicate more effectively and take responsibility for each of our tasks. We can also learn to work together and appreciate the importance of teamwork, which is evident when we discuss the assignment, collaborate on recording the video, measure the data, and create the slide together. Last but not least, the study also highlights how geometry contributes to preserving artistic values cultural identity and structural harmony, making it an essential element in both mathematics and architecture design. Okay, for this is our AI detector for this assignment, which is for part A we get 0%, same with part B we get 0%, and for part C we also get 0%. Okay, so that's all from us. Thank you.